All right, now let's take a look at how the Python language works with variables and data types. So in my editor, I'm going to open up the variables_start file. And there are 5 major data types in Python. There are numbers, such as integers and floating point values, strings, which are a collection of characters, Boolean values, which can be either true or false, sequence types, such as lists and a data type called tuples, which are immutable, meaning they can't be changed, and dictionaries, which map unique keys to specific values. And so you can see here, I've defined a set of variables that represent each of these data types, and I have a set of print statements that print each of these values. So before we do anything else, let's just go ahead and run what we already have. So I'll right-click and choose Run Python File in Terminal. And remember, if you're not using VS Code, you can just run this in your terminal program like we saw earlier in the course. And you can see that the output contains the values of each of the variables that we've defined so far. All right, so far so good. Let's go back to code. All right, let's try adding a couple of lines. I'm going to write my int equals ABC. Okay, and then I'll print my int. So now I've got my int equals ABC. So basically, I'm redeclaring the variable that was declared up here previously as a number. So now I'm declaring it as a string. So let's go ahead and run this. And you can see that it works. It started out as an integer, but now it's a string. So even if a variable has already been declared, you can redeclare it with a different type, and that works just fine in Python. All right, let's keep on going. Okay, let's take a moment to look at sequence types. So for sequence types like lists and tuples, we can access individual values using a square bracket notation with the index of the item that we want, starting from 0. So to take an example, if I wanted to access the third item of my list, I would write something like this. I would write print my list. And then remember, it's a 0-based index, so I would use index 2. And the second item of my tuple, for example, would be index 1. And you can also use what's called the slice notation to access a subset of a sequence. So for example, if I wanted to get the first index here all the way to the end of my list, I would write something like this. So I'll print my list. And then I'm going to write 1 and then colon and then the number 5. So basically the 2 indexes that I want to get a subset from. And slices also take a third optional parameter, which is what's called the step value. In other words, it's how many items to skip over. So for example, to get the 2nd through the 5th items in my list while skipping every second one, I could write something like this. Let me just copy this and paste it. So basically, this is the start index, the end index, and the step value. Okay, so let's go ahead and save. And let's go ahead and comment out the previous prints to avoid muddying the output. All right, and we've already seen this one too, so we can comment that out as well. All right, so let's go ahead and save, and let's run. And now you can see that we're getting, let's go ahead and scroll that up. All right, so we have the third item in my list, the second item, which is index 1 of my tuple. Here we have items 1 through the end, right? So this is the 2nd, 3rd, 4th, and 5th item in my list. And this is the 2nd and 4th item because we're skipping every second one in my list using the step value. All right, let's keep on going. So what's interesting is you can use the slice notation to actually reverse a sequence. So there's a neat little trick you can do. I'm going to print my list. And then inside the square brackets, I'm just going to put 2 colons and then a -1. So I'm not specifying a start value. I'm not specifying an end value. So it's going to be the default start and the default end, which is the entire sequence. And then the step value is going to be -1. So this is actually going to reverse the sequence. So if we save and we run, you can see that now, here's the original sequence, and here is in reverse order, just by using the trick right here to do the minus step. Okay, so far so good. Let's go back to the code. Let me comment out the previous calls here. All right, dictionaries are a little bit different. Dictionaries don't work with indexes. What happens is you give them the key of the item that you want, and they return the value associated with that key. So if we scroll back up and we look at the dictionary here, we can see that the string 1 maps to the value 1 here, and the string 2 maps to the value 2. Now in dictionaries, the keys have to be unique values, but the values don't have to be unique. So if I wanted to retrieve the value associated with this key of 1 right here, what I would do is write something like this. I'm going to print out my dict, and it's going to be inside quotes the key of 1. Right, so let's go ahead and run that. And you can see that the key of 1 maps to the number 1. Okay, let's go back to the code. So let's make another change, and let me go ahead and comment that line out. All right, let's see what happens when I try to combine 2 different data types. I'm going to print a string type. Right, so this is a string, and then I'm going to use the plus operator with the number 1, 2, 3. All right, so I'm going to save that, and I'll try to run it. And you can see that I'm getting an error, and right here you can see specifically I'm getting a type error. And this is happening because Python is what's called a strongly typed language, even though you don't have to declare the type of a variable before you use it. So what happens is when Python goes to execute this code, right here, it infers a specific type for a value or a variable. So you can't go back and change the type or combine it with other types. So I've got a string, and I've got a number, which are 2 different types. I'm trying to combine them. In Python, this doesn't work. You have to have all the arguments be the same type when concatenating a string like this. So let's make an adjustment. I'm going to use the stir function to convert the number into a string. So what I'm doing here is using this built-in function in Python called stir. And that's going to convert this integer into a string. So that way I'll have a string plus another string, and that works just fine. So let's go ahead and save. And close that terminal and run this again. And now you can see that that works just fine. It's printing out string type 1, 2, 3, just as we would expect. All right, a couple more things to look at. Let's take a look at global versus local variables. So go ahead and comment that out. So I'm going to define a function and add some code to it. Now, I don't expect you to understand this right away. We'll get into functions later in the course, but for now, just bear with me. So I'll declare a function called sumFunction, and I'll have a variable called myStir, and I'll assign it the value of def, and then I'll print myStir. All right. So inside the function, you can see that I've got these 2 lines indented by some spaces, indicating that they belong to this function here. So in Python, indentation and white space matters. So I've got myStir equals def, and I'm printing myStir. Now remember, if we scroll back up, I've already declared myStir up here. And so I've got my myStir variable here that's global, which is set to this is a string, and I've got my local variable here, which is set to def. So let's add 2 more lines. I'm going to call the function, and then I'm going to print myStir. So let's go ahead and run and watch what happens. So you can see that when I run this, the value gets printed def, which is inside the function. But even though I've reassigned the value of my stir to def, once we get outside the function, it's back to being this is a string again. Now, that's because when you're inside a function definition, the function gets its own local copy of whatever variables you declare inside the function. So this variable, my stir, right here, is different than the global one that's defined up at the top. Now, if I actually want to affect the value of the global variable, I have to tell the function that there is a global variable named my stir, and that's the value it should make changes to. So what I'm going to do is I'm going to write the word global, and then I'm going to use the variable name of my stir. So the global statement with the name of the variable indicates to Python that this variable exists in the global namespace and is declared somewhere else. So now if I save this, and let's close that terminal and run it again. See, now you can see that def is being printed twice. And the reason is because now I'm affecting the global value outside the function, because I've told Python, hey, that's a global variable. When I change the value, it's going to affect the variable globally. So let's make one more change. Below this code, I'm going to write del, my stir, and then I'll try to print it again. The del statement deletes the definition of a variable that was previously declared. So when I get to this line here, print my stir, there should be a problem. It should give me an error because that variable is gone now. So just for clarity's sake, let's make sure that all the functions are commented out, and yes, they are. All right, so I'll save, and I'll run. And you can see, sure enough, here's the previous code. We're printing out the def twice, and then you can see name error, name my stir is not defined. And that's because right here on line 54, I've deleted the variable, which essentially means you can undefine variables in real time by using the del statement. All right, so that's a quick look at using variables and data types in Python. And we're going to take what we've learned in this video, and we'll use it throughout the rest of the course.